I have recorded the lecture. So it is the time 3:30 now. So by this Sunday, you have your exam, which is online. 10 questions with multiple choice I have given. Questions are coming from basic principles of counting, permutation, combination, and then set theory, and then probability, computation, and like some word and how many ways you can arrange those things, and how many sample points. Those are the questions coming. So if you look at the YouTube channel, how can I log into my YouTube channel? gmail.com, and I clearly explain in the email, right? In the email, I clearly explain and give you the link of the YouTube video channels, right? So if you watch those YouTube video channel, then you would not have a problem. MRUC C77. That is what I forgot. So many passport. I'm sorry, I don't want to go there. And they will ask me thousands of questions now. Okay. So everyone ready for the exam, right? 3 videos or 4 videos that I have uploaded in the YouTube channel. You can watch those things. When you watch and write, understand? Write a note in your things. In that way, when you will prepare for the exam, when you sit for the exam, you can answer the question correctly. Clear, right? When you will prepare, when you watch, suppose today is Tuesday, right? You have Sunday, up until Sunday, 11:59. So 3 videos, so it could be around 9 hours. So 9 hours means if you watch one day, one video and take a note by pausing, okay? Then what you can do, you can take a better preparation for your exam, okay? Now, from today, I'm going to discuss probability distribution. Probability distribution. This week and next week, I'm going to cover these distributions. Number 1, binomial distribution. Number 2, geometric distribution. Number 3, negative binomial distribution. Number 4, binomial distribution, geometric distributions, negative binomial distribution, Poisson distribution, and number 5, normal distribution. Okay? These are the distributions I'm going to cover in today and next week. Clear, right? You are understanding. These are the distributions I'm going to cover today and next week. Okay. Let me start discussing what is binomial distribution. Number 1, binomial distribution. Okay. So if I toss 4 coins tossing experiment, 4 coin tossing experiment, what I have? HH, HT, TH, TT. Here HH, HT, TH, TT. Okay. These are the 4 coins tossing experiment. So I have here H, right? So how many heads in here? There are 4 heads. Here I have H, T. 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 Okay. Here I have T, H. Here I have T, T, and then T, T. Here I have T, T, and then here I have T. Okay, clear, right? 4 coin tossing experiment, right? 4 coin tossing experiment, right? Now I want to put X equal to number of heads, right? Then what I have? 0 head, 1 head, 2 head, 3 head, 4 head, right? So now I can write here 4, 3, 2, 3, 1, 4, right? Right. Are you getting these things? 2 head, 4 head. Clear, right? Now I want to find probability of X equal to 0 head. Probability of X equal to 0 head equal to 1/16. Do you understand or not? Are you understanding? Okay, so now probability of X equal to 1 head. X equal to 1 head. Where is X equal to 1 head? Here is X equal to 1 head, right? Sorry, I draw here. This is 0 head. This is 1 head. This is 1 head. This is 1 head. Rest of the thing is fine. Okay, good. Okay, so now this is 0 head. This is 1 head. This is 1 head. This is 1 head. And HTT, this is 1 head. Sorry for the confusion. Understand? I'm sorry. Okay. Now 1 head equal to what? 4/16, right? And then 2 head, X equal to 2 head equal to what? 6/16. X equal to 3 head, which is equal to 4/16. And X equal to 4 head equal to 1/16. Clear? Are you understanding? Are you okay? Now the problem is, suppose I want to toss the coin 10 times. If you toss the coin 10 times, what will happen? How many sample points? If you toss the coin 4 times, you are getting 16 sample point. If you toss the coin 10 times, then you are getting 1024 sample points. Are you understanding? I want to solve this type of problem. A coin is tossed 10 times. Find the probability of exactly 7 head. Find the probability of at least 2 head. How can you do that? Are you understanding? You, your parents, your grandparents, your spouse, and lot of people, if you will take together and start constructing sample space, 1024 sample points. How many hours needed? Lot of, right? Lot of hours needed, right? But scientists, our forefathers, they gave us a formula. we are going to use that formula known as the binomial distribution to compute those type of probability. Clear? For example, if I want to compute this should be 4 coin, 4 choose 0 head, p to the power, like p means half, p equal to probability of head, half to the power 0, 1 minus half to the power 4 minus 0. That will give us 1/16. This one is 4c1, half to the power 1, 1 minus half to the power 4 minus 1, equal to, you will get 4/16. 4/16. This is 4c2, half to the power 2, 1 minus half to the power 4 minus 2, which is equal to 6/16. This is equal to 4c3, half to the power 3, 1 minus half to the power 4 minus 3, equal to 4/16. This is equal to 4c4, half to the power 4, 1 minus half to the power 4 minus 4, equal to 1/16. Do you understand? So now the formula, general formula is capital X equal to small x, and C x p to the power x, 1 minus p to the power n minus x, and x equal to 0, 1, 2, 3, 4 up to n. Clear? So that is the formula. This is the formula. And this is the question. What is the question? Now let me write the question. A coin is tossed 4 times. Okay. So a coin. So I want to add here a fair coin. Understand? I add here a fair coin. I request you to write these things. I know all of you are writing. You are typing or you are writing. Right? If you write, what will happen? Then at your home, you can practice it again. A fair coin is tossed 4 times. Find the probability of getting exactly 2 heads. Okay, exactly 2 heads. Exactly 2 heads, that means this. Clear? Now I want to do exactly 2 heads. Now at least 3 heads. At least 3 heads means what? Can any one of you tell me?
3 or more.
So that means probability of x equal to 3 and probability of x equal to 4, right? Right? At least 3 head. Probability, find the probability of at least 3 head. Are you understanding? So now you can find it. How? At least 3 head equal to 4/16 and 4 head equal to 1/16, which is equal to 5/16. Are you understanding? The quiet boy in here, are you okay? Yep. Good. At most 2 heads. At most 2 heads means what? Someone else can volunteer. At most 2 heads means what? How many heads? At most. At most 2 head means what? So that means 0 head, 1 head, 2 head, right? At most 2 heads, so that means maximum of 2. So 0 head plus 1 head plus 2 head, right? So now how can you do that? 0 had equal to 1 over 16, 1 had equal to 4 over 16, 2 had equal to 6 over 16. So you have 11 over 16. That is the probability. Are you understanding? So now what you understand? Now I'm going to write a problem. We'll solve it. Then we are done with the binomial. Okay. So this is the binomial distribution mathematical formula. NCX p to the power x 1 minus p to the power n minus x, and then x takes value 0, 1, 2 up to n. It has a mean, could be written as expected value of x equal to np, variance which is equal to variance of x equal to np and q. Q means 1 minus p. Q equal to probability of failure. Probability of failure. And p equal to probability of success. Probability of success. My online student Grace, are you understanding? Grace Osibanjo.
Yes, sir.
Good. Clear, right? So now we are going to solve a different type of problem. And after solving that problem, I will give little bit of explanations. Then we will go another distribution. Okay, everyone ready? Everyone ready? Okay. Okay. Take a look. A hospital has 50 patients. Probability of COVID patient is 0.45. Understand? A hospital has 50 patients. Probability of COVID patient is 0.45. Okay. Find the probability. Let me write in here. Find the probability of getting exactly 20 COVID patients. Clear, right? Exactly 20 COVID patients. So how can we do that? Let me take a black color. So probability of x equal to 20, right? 20. So how can I do that? 50, choose 20. Probability of COVID patient is 0.45 to the power 20. 1 minus 0.45 to the power 50 minus 20. See, take a look at the board, please. Are you seeing this formula? It's coming from that one. Okay? Clear, right? That is the way you can compute probability. Now, find the average number of COVID patients. Find the average number of COVID patients. How can you find the average number of COVID patient? Mean equal to average equal to NP, N equal to 50, COVID patient probability equal to 0.45. That is this formula. I applied this formula in here. Average distance of each data from each data point. So variance equal to what? NP 1 minus P. Clear? So N equal to 50 and P equal to 0.45. 1 minus P equal to 0.55. So multiply this, will give you the result. Anyone of you in this classroom know R? R? You just know Python, right? Okay. Now, this is what by using paper and pencil approach, right? This is paper and pencil approach. Paper and pencil approach. Right? I ask you, advise you, request you, order you to spend next 5 minutes to find Python code to compute binomial probability. What you will do, go to the Google. I know the code, I know, but I am going you training how to find the code. Python code to find binomial probability. And I want to see whether these results you can get, okay? What is the results in here? Let me compute it by paper and pencil approach, and by using R, I want to compute, and then that is known as the, you understand the problem, right? What I ask, so that is choose 50, choose 20 times 0.45 to the power 20 times 0.55 to the power 30. This is point. Okay. Now I want to do P binom, Q binom, D binom. 50 choose 20, 0.45. Okay. I want to see who can find this result. This is what 0.0880. This is what I use R. Are you seeing R? Are you seeing R written there, right? R is similar to Python, understand? When you do your job search, when you go to the job place, some people are using R, some people are using Python, but they are the same. Okay? Python was developed by computer science people, R is developed by statistics people. Okay? So anyone find this result by using Python? In the Google search Python code to find probability from binomial distribution. Anyone? Did you? If you find, could you find these things? Like, is it okay? Can you get this one? Okay. I think Fantastic. Binomial PMF X. One student, I think Grace gave us the result. Binomial PMF. Let me see if it will work or not. Copy. So Grace, do you need to install any software?
I used Jupyter Lab.
Okay, she put these things. This is equal to 0.45, and then this is equal to 50, and this is equal to 20. Let's see whether it will work. Binomial is not found. Okay, binomial is not found. Anyone else?
Import Skippy, from Skippy, import stats, and then just do stats in front of what you.
Okay, so from what?
SCIPY.
SciPy,
Oh, yeah.
import.
Stats,
Okay,
then stats.
after using this, then you have to use this one, right? Now it will work.
Stats goes in front of it.
Start.
Stats.
Don't.
Are you seeing? The reason I asked you to do these things so that you will understand. Listen, nowadays, upcoming days, when you finish more and more courses, maybe go to the graduate school and then in your professional life, you cannot remember a lot of things because now in one head has lot of things. Understand? So if Google is gone, suppose from tomorrow Google is gone, you see mental depressions of the people. Now we have to works, like within 1 hour we can do lot of works. The same things we have to do by using maybe 1 day. Understand, right? So you have seen how to compute this probability. Now, can any one of you also compute? This is what you have compute. You have compute exactly 20 COVID patient, right? So now I want to do at least 30 COVID patient. 30 COVID patients. At least 30 COVID patients mean probability of X greater equal to 30. So that means probability of X equal to 30 plus probability of X equal to 31, and it will go up until probability of X equal to 50, right? Do you agree these things? How many is probability I have to compute? 21, right? At least 30 COVID patients. How many probabilities I have to compute? 21 probabilities. Is there any code to compute that probability as well? Are you understanding? Are you understanding? What is that? This is called CDF. So if you want to do, I think PMF, CDF, And then if you put here 29, I will explain this. 1 minus this, we'll got that one. I have to explain this. Okay. First question was what? A hospital has 30 COVID patients. Probability of COVID patient is 0.45. Find the probability of exactly 20 COVID patients, which we have done by paper and pencil approach as well as by Python approach. Now, how can I compute probability of at least 30 COVID patients? So 30 COVID patients, paper and pencil means you have to compute 21 probabilities. And that will take a lot of your time. But we are expert in Python. How can we compute this? So finding this probability means probability of x greater equal to 30 means 1 minus probability of x less equal to 29. Do you agree with that or not? Do you agree with this one? This boy, are you okay?
Yeah.
Are you understanding?
Yeah.
So if I compute manual approach, suppose there is no computer around the world, dirty nuclear war, make the world no computer, no electronic devices, okay? Then you have to compute these 21 probabilities. That will cost maybe 1 hour of your life or more than that, right? But now we have a software. By using software, we can compute that. What is the software things? 1 minus state binom CDF 2950.45. Let us check these things by using R as well. So this is called 1 minus P norm. I'm checking in both way 2950 and then 0.45 and then do these things. 2950 P norm. That is not right. D norm. Okay, so let me check these things in there. Why? Okay, let me check one thing quickly. P norm. P norm means distribution function. Oh, sorry, I am very sorry. You need to correct me. It's P binom. P binom 0.0235. Let's check. 0.0235. Are you seeing? Same result, right? This girl, are you okay? Looks like you have confusion. No? Clear, right? So what I did, I took a small scale binomial distributions problem by tossing a coin 4 times. Okay? And then I show you parallel how to compute those probability by using formula approach and then by using manual approach. And then I take you to another real life example of COVID patients, and I have computed probability by using Python as well as by paper and pencil approach. So you are okay, right? So now let me do another one. So at least 30 COVID patients. Now, if I want to do at most 20 COVID patients, 3 at most 20 COVID patients. At most 20 COVID patients, how can you do that? Probability of X less equal to 20. Okay, at most 20 COVID patients. So how can you do that? Probability of X equal to 0 COVID patients, X equal to 1 COVID patients, and go all the way probability of X equal to 20 COVID patients, right? Now, which you can do at most, just come here, you can do this. This is the at most one. Put here 20. Okay, take a look. This is a at least 1 minus at most equal to at least. 1 minus at most equal to at least. Clear, right? You can write it down. 1 minus at most equal to at least. Write it down. 1 minus at most equal to at least. And this is the at most one. Okay. CDF means at most one, and 1 minus at most equal to at least. Okay, before concluding, now I'm going to tell you very important thing. Okay, pay all of your attention to my words in order to get this problem correct in your exam. So what is the problem? Problem is, in your exam time, how do you know a problem is a binomial problem? Understand? How do you know a problem is a binomial problem, and how to use 1 minus state dot binomial CDF, or just state dot binomial CDF, or state dot binomial PMF? These are the three formulas you have to use to solve problem in your exam. Clear, right? Before that, you have to install line number 4 from SciPy import stats. Okay, from SciPy import stats, this is the thing you have to, this package you need to install. Okay, how do you know a problem is a binomial problem? By reading the question, if you see there are two categories, yes and no, disease, no disease, head, tail, okay, winner, loser. When you read the question, if you find there are two categories, failure and success, and success probability or failure probability will be given, and total number of trials is fixed. If you read the question and you find these three things will help you to identify, three things will help you to identify a binomial distribution. Binomial distribution. Number 1, n equal to number of trials is fixed. What do you mean by number of trials? Number of patients. Number of patients in a hospital, or number of coins tossed, or number of die thrown. Understand? Number 2, always two categories, always two categories, success and failure. Even a dice has a 6 category, right? But target is 5. So 5 is one category, rest of them are another category. Are you understanding? What did I say? Suppose a problem has a 6 category, a dice has a 6, right? But I say 2 categories, right? Always 2 categories, right? A dice has a 6 point, right? It has a 6 point. My focus is 5. 5 is one category, rest of them is another category. Clear, right? Even there is multiple category, but you can categorize them as two. For example, there are 6 number. Odd number is a one category, even number is another category. Clear, right? You understand? Always two categories, and probability of success or failure must be given. Probability of success and failure are given. Okay, suppose success category P equal to 0.64. Then failure probability Q equal to 1 minus P, which is equal to 1 minus 0.64 equal to 0.36. Do you understand this? That's the end of the discussions. I have given you theory, I have given you mean, I have given you standard variance, and then I have discussed two problems. Now I am going to discuss another probability distributions. Yes.
Scroll up to the.
Sure.
Up the first page.
More?
Yeah, I just wanted to see the question that you asked, so I could write it in my notes. Thank you.
Yeah, right? Now I am going to discuss geometric distribution. So binomial distribution finish. Okay, we send it to the graveyard. Now let us discuss about geometric distribution. Geometric distribution. Very easy, lot of applications in our life, where whether we want or not, continuously we are using geometric distribution in our life. Understand? Whether we believe it or not, whether we understand it or not, whether we want it or not, we are continuously using geometric distributions in our life. Okay? That is a very good introduction, right? We are continuously using geometric distributions in our life. Okay. Most of the time in our life, we are happy with only one success. Are you understanding? One good college admission, one good job, one good car, one good home, one good spouse. Understand? You understand? But before getting admission to the college, how many times you try? You tried 15 colleges, then you got the success one, right? Failure, 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 success. Failure, 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 success. You give job interview, job interview, job interview, and 7th time you got the success. Understand? How many failures? 6 failures. So you have a series of failure until you get the success. If this is the scenario, then this is called the geometric distribution. Understand? So geometric distributions mathematical formula looks like this. Take a look. Probability of x equal to x equal to failure. Q equal to probability of failure. Failure, 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 and then success. How many failures? 6 failure, right? And 1 success, right? So can I write like this? Probability of qx minus 1, then x takes value 1, 2, 3, 4, 5, 6, and 7. Here x equal to number of trials. Okay. Here x equal to number of trials. Okay, this is written like that way. And also geometric distributions can also be written x equal to x, q, 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 p. It could be written as p q to the power x. Here x equal to 0, 1, 2, 3, 4, 5, 6. Are you seeing the difference between these two? In this case, x equal to number of failures. I'm going to spend a couple of minutes in here in order to clarify the concept. Okay, in order to clarify the concept, I'm going to discuss this thing little bit. Okay, so let me explain these things to you. First one, you have seen number of trials. Okay, first one you have seen number of trial. Second one you have seen failure. This is the way main difference. Down the road in your life, you see this one and that one. Only difference is here x equal to number of trials. For example, I told her, she invited me for a coffee. Okay, she invited me for a coffee at her. No, she invited me for an apple because she grew up apples at her home. She invited me to take an apple from apple tree. So she decided that she will get the apple from the apple tree by stoning. Are you understanding? How are you getting the apple? By stoning. Understand? So she had a lot of stones in there, and I went to her home. She took the stone and she threw in the apple tree. She did not get failure, right? She again throw, and again throw. So that is called the number of trials. So that means she made seven stones. 7 stones she throw. 6 is failure and 1 is success. Clear, right? Clear, right? So this is the number of trials. So 7 stones she throw. So that means those stones will be the number of trials. On the other hand, she throw stones in there. In this case, she got 0 success. Sorry, 0 failure, 1 failure. This is the 1 trial, 2 trial, 3 trial, 4 trial, 5 trial, 6 trial, 7 trial. This is 0 failure, 1 failure, 2 failure, 3 failure, 4 failure, 5 failure, 6 failure. If 0 failure, that means she got the apple in her first try. So you understand these two things, right? So most of the time in our life, we are happy with only one success, only one home. You are doing a home shopping. Okay? Oh, I don't like this house. Oh, I like that house. Well, we cannot afford this house, but let's go and check. Down the road, when you will go out for the shopping, these are the things come to your life because we go through these things. Car shopping, no, we want to buy SUV. Most of the time in our life, we are happy with only one success. Getting a one college admission, getting a one job, getting a one car, getting one, buying a home, or having a good spouse, and then having a child, something like this. By reading the question, if you see that there is a problem of only one success, and before that a series of failure, then it will be your by geometric distribution. So let me solve a problem. Okay. Let me solve a problem. What is the mean of this? That is what I'm going to now discuss. Mean is this. Mean equal to 1 over Q and variance equal to 1 over Q or 1 over P. I think P over Q. P over Q. RQ over P. No, I'm RQ over. Sorry, I make a mistakes in here. 1 over P and this is Q over P. Q over P square. This is the mean and variance. Clear, right? Now let me write a problem. Let me write a problem now. Probability of meeting a former US president is 0.15. Understand? Probability of meeting a former US president is 0.15. Find the probability that a person meets President Clinton. Find the probability that a person meets President Clinton at 9th try. So 9th try means how many failures? 8 failures, right? So you can write here probability of X equal to 9. Okay. And then what is the probability of meeting a president? 0.15, right? So I put here P15, 1 minus 15, and then 9 minus 1. Are you understanding? Point 0.5 times 1 minus 0.5 to the power 9 minus 1. So now find the average number of trials. So now find the average number of trials needed to meet President Clinton. Average number. So the probability, what is the mean? Mean equal to 1 over P, right? Mean equal to 1 over P. So P equal to what? 0.15. So 0.15, 1 over 0.15 equal to what? 1 divided by 0.15. 6.66. Oh.
She wants us to round up. And there was multiple. Decimal places.
Here 6.66, right? You can put maybe 7 because it is a discrete number, right? You can put here 7, or but you should not put here 6. Very easy. Geometric distribution is very important and useful. Now all of you are trying to get A, right? So probability of getting A and probability of not getting A. So that is the way when you read the question, there is no hints, there is no clue, there is nothing in reading the question, whether it is binomial or geometric or negative binomial. You have to decide by reading the question. Clear, right? When you see until one success, until you get your desired result, and last trial is a success. Last trial is a success. She put the angler in the river until she get a rat snapper or salmon, because I like salmon very much. Understand? So probability of getting a salmon must be given. Otherwise, how can you compute this probability? So now you can ask me question, hey professor, how can you get this probability? This is coming from previous experiences. Okay? Previous experiences, those probabilities are there. So you can say, so for example, you put the angler, your bait is taken away. Second time you put, you got. And then 10 times you try, you got the 4 fish. So that means 4 over 10. So that means 40%. This is the prior information you are going to use in next time. Okay. Now I am going to use negative binomial distribution. Okay. Negative binomial distribution. In your exam, I will give you just the problem. You understand the problem and you will solve it. Clear, right? Now, negative binomial distribution I am going to solve, which is an extension of the geometric distributions, and real life problems will be solved. Then I will give you 5 to 10 minutes to find the Python code. Okay. Okay. Negative binomial distribution. Negative binomial distribution. Okay, negative binomial distribution, it has a mathematical format like probability of x equal to x plus r minus 1 c r minus 1 p to the power r and 1 minus p to the power x. Okay, this is. So x equal to what? X equal to 0, 1, 2 up to infinity. So x equal to number of failures. Okay, and then r equal to number of successes, p equal to probability of successes. These are the things. X or P. So we are going to use these distributions to compute probability by paper and pencil approach. When we were undergraduate student, we used paper and pencil approach. Computer was very expensive during that time. Now we are going to learn by paper and pencil approach as well as by Python approach. Clear, right? You are understanding, right? This boy invited me, my wife, and my 2 daughters at his home for dinner. Clear, right? And he asked me, Professor, what do you want to eat? I said that we like tilapia fish, salmon fish. That's name. He said, well, I am a good angler, I can catch 4 fishes for you. In a state of one success, geometric distributions, you are searching only one success, right? In a state of only one success, if you are trying for a specific number of success, until you get a 4 red snapper fish, he put the angler in the river, did not get it. Second time, did not get it. Third time, he got it. 7th time, he got the second. 13th time, he got the third. And 21st time, he got the 4th. Okay. So 21 time, he got the 4. So how many failures he has? 17 failures, right? How many success? 4 success, because we are 4 members. So in a state of only one success, in a series of failure, if there is a success, failure, success, failure, all of these things is coming, then it will be negative binomial distribution. Understand? So for example, let me write something in here. Each of you are trying to catch 4 fishes. Okay. Each of you are catching 1, 2, 3, 4, 5, 6, 7, 8. 8 people are in here. So you are trying to catch fishes. So failure, success, failure, success, failure, success. So 1 success, 2 success, 3 success, 4 success. Okay. How many failure? 1, 2, 3, 4, 5, 6, 7. So that means there are R equal to 4 and then X equal to 7. Altogether X plus R equal to number of trials equal to 11, right? So I was explaining what is negative binomial distribution. So negative binomial distribution, so this is one of you. Suppose this is, what is your name? So first letter start with C, right? Okay, this is her. Now, suppose your name is
Jana.
J, right?
Yep.
So now let us try this one. She tried to catch fish, failure, success, failure, success, failure, success. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then success. So now 4 and X equal to 7 and X plus R is the same. But now see, Jana's combination is different from her combinations, right? So her combination failure, and then success, her success, failure. So, but the number of success, number of failure are the same. Are you understanding? So another person, suppose the name is M. So this is failure, success, failure, success, failure, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is what. So the different combinations you are getting, right? Success, failure, different combinations. Different ways these are coming. It is still R equal to 4 and X equal to and X equal to 7. So try to understand. I want you to ask you to take a look at the board in order to understand. See, these success and failure combinations are different, right? 4 successes are coming, 7 failures are coming, but the combinations are different. Clear? And once you get the 4th success, you are done. So that is why last trial is always success. When you get the 4th one, you are done. Clear, right? When you get the 4th one, last one is done. So that is why last one is always P. Now, last one is always P. In this case, how many success and failure? In this case, there are X plus R minus 1 trial, because in this case, why I put here -1? Because last one is success, I don't want to consider. But X plus R equal to, all of these equal to 11, X plus R equal to 11. 11 minus 1, so I do not want to consider that one, because that one is always success, okay? And I want to find how many ways this can be combined. That can be combined C R minus 1. Why R minus 1? 4 successes, 1, 2, 3, and 1, 2, 3, 4. So I want to compute here how many ways 3 successes could be done. That 3 successes could be done like this way. This is 11 minus 1 C 4 minus 1, that could be written 10 C 3. So that means in this case there are 10, there are 10, there are 10. Out of these 10 trials, how many ways 3 success could be obtained? So that is why they have written like that way. Are you understanding? Okay. So as you have understand these things, this mathematical formula, let me write the mean. Mean equal to RQ over P. In order to get R number of success, how many trials on an average needed? This is equal to average number of trials. Average number of trials and variance. RQ over P square. So now we want to solve a real life problem. Are you understanding? Are you ready? We are going to solve now real life problem. Understand? So I started discussing binomial distribution, where number of trials is a fixed. A hospital has 10 patients. A coin is tossed 15 times. Okay. So and McDonald has 15 employees. Okay, the probability of a adult employee, adult means above 40, is 0.25. So number of trials is fixed, but the geometric and negative binomial distributions, you do not know how many trials is needed until you get a required number of successes. Okay, until you get a required number of successes, you do not know. So now I want to solve a problem. probability of finding oil from oil is 0.19. You understand, right? Probability of finding oil from well is 0.19. A oil company digging well to get oil. You are understanding, right, the problem? Find the probability that find the probability that nineteenth well needs to be dug until 19 oil needs to be dug until 7 wells give oil. Are you understanding? So what is the target? What is the target? Your target is to get how many fish? If you want to invite me, my wife, and my 2 daughters, your target is to get how many fish? 4, right? So what is their target?
What, 7?
7. Right? Their target is to get 7, right? Are you okay? So then what is R? R equal to what? R equal to 7, equal to number of successes, right? X equal to what? $12, right? Number of failures, right? Number of failures, right? Now we want to compute what? Probability of X equal to X and then X plus R minus 1 C R minus 1 and probability of R and Q, which is equal to 1 minus P and then X. Now I want to put probability of X equal to 12. 12 plus R equal to 7 minus 1 C 7 minus 1 P equal to what? 0.19 to the power 7, 0.81 to the power 12. Do you understand these things? So another Okay, once you finish writing, then I will speak. Another hint, not to be confused among three distributions that I have covered. Binomial distribution, negative binomial distribution, geometric distribution. In geometric distribution, always only one success, and last trial is a success in a series of failure, success. Okay, last trial only one success. In negative binomial regression, a specific number of success. Okay, the guy will not start a job unless he get a 7 job offer. Okay, you understand? This girl will not stop buying unless her dad buy for her 4 different dress for the Halloween. Okay, a specific number of success. And also in the binomial and negative binomial distributions, most of the time you will see the word until I get the job, until I get 4 successes. Are you understanding? In negative binomial and as well as geometric distributions, you might high chance of seeing the word until I get 4 jobs, until I get a success. Okay. So now I can compute these things by using this, which is in here. I can write it in here. So 1918 C6 0.19 to the power 7 0.81 to the power 12. Let me compute these things by using. Now I ask you, find the negative binomial formula to compute this by using Python. So let me do it by using first R. So that is choose, and there is a 6, 12, 6 and 12, right? 18. No. 18 choose 6. Yeah, 18 choose 6. 18 choose 6. Point 19 to the power 7. 0.81 to the power 12. Did I write things correctly? Okay, so it should be other way. I should write like this way. That's the way. Okay. 0.0132. 0.0132. 0.0132. So now I want to compute it by using Python. So Python, I think, let me do this one on to state binom. Let me see if it will work. N binom. I put here N, and then I have to put here. I have to put here 7 success, 12 failure, Probability of 0.19. I don't know whether it will work. No, it is not working. It will not work. Let me check. State and binomial. Okay, could you find this one? Let me check. This is it should be 7 success and 19. Let me check whether this is no. What we are getting in there? 0.0132. 0.0132. Python code for negative binomial. Okay, I want to give you some time, 10 minutes. Like the way you find previous code, you find this code for me, right? How can you find this code for the negative binomial distribution? Find that thing for me and let me know. Did anyone find? What? You find it? What is it?
Put from scipy.stats, import and binomial.
Okay. So in the R, I found these things. So this is a manual competition, right? This is a choose. So that means 18 choose 6 times 0.9 to the power 7 success, 0.81, which is the failure probability times 12. That will give us this result, and this is by the formula. Is density of negative binomial 12, number of failures, number of success, probability of success. I got this. So these two is matching completely. Okay. So now this is true. This is manual computations. I want you to find these by using Python. So what is the code? Could you tell me?
I've been from
What?
from scipy.stats with the import and binomial.
Oh, we have to do that one.
I think so.
So let's see. From scipy import and binom like this. Okay. And binom from scipy import and binom is not finding.
I think at least the one I found online says you can do
What is the spelling of the binom?
just like that. It says if you do scipy.stats import. That's what it says.
Oh. Like this?
Yeah.
Okay, and then
Then, this is right, but it says RV equals not, N binom. Sorry. Let's show you.
no, that is not right. No, that is this is manually computed.
Oh,
X and P. Okay, let me try that X and P. Just the PMF. PMF. X and P, X and P, X equal to failure. Failure is 12, N equal to 19, and P equal to 0.19. I think so. I put out the stress. See. No, it didn't work. Okay. Some other people, please help me. Because you need this. Why you need this? Because you need this so that you can quickly solve the exam problem. I want here Python code. I want here Python code. Find it. Python code to compute probability using negative binomial distribution. You find it?
Yeah.
Okay, come please. Stress.nbinom.pmf. So same thing I did, but why it did not work?
I
then?
put the 12/7, then 19.
So this is the what I also put. See, let me see. State binom, state and binom.pm. Oh, you put. Let me see. How did I put it in? Oh, I put other way. I put other way. See why my one was not obtained. Here should be 7 and here should be 12, right? Okay. So this is the code you have to use. write down this package and code, because when you take the exam, this code, if you use, you 2-hour exam, you can finish just 20 minutes. So geometric distribution computation is very easy. It is just P times 1 minus P to the power x minus 1. That is what you can compute manually. But binomial and negative binomial, there is a one line of code. That code, if you know, and if by reading the question, if you understand that your problem is a binomial problem or a negative binomial problem, then if you use this code, then it is easy. So binomial and negative binomial, how many types of problem I am going to tell you. Binomial has a exactly 10 COVID patients, at least 10 COVID patients, at most 10 COVID patients. How many? 3, right? Exactly, let me write it so that you might forget. So let me write it so that you would not have a trouble. Exactly, at least, at most. Okay, mean, variance. This is for binomial and negative binomial. Clear, right? Now, as your friend Jenna showed here, so when you want to do CDF, if I pushed here C, okay, then see what is happening. Okay, C is not working in there. CDF is not working there. No, CDF, it should be CDF. CDF. Now it will work. Okay. So now in this case, there should be like at most. Okay. And 1 minus at most equal to at least. You have written down all the notes, right? So for the binomial, negative binomial, 5 types of problem you will encounter. How many fingers? Okay, exactly, at least, at most, mean, variance. Okay, for binomial and negative binomial, 5 fingers, 5 types of problem. Exactly, at least, at most, mean and variance. And for the geometric distribution, just only one problem. Okay, until I get a first success, until I made the president. Probability of trying to make NBA player is 0.25. Okay, what is the chance that I will meet the NBA player in 11th try? So 10 is failure and 11th is a success. Okay. Okay. So now let me start another distribution known as the normal distribution. So next week I will finish normal distribution remaining part, as well as today I'm going to finish some part of the normal distribution. Okay, then 5 distributions exam: binomial, geometric, negative binomial, normal, and Poisson. Okay, 5 distribution. Are you understanding? I request you, suggest you, advise you, and order you watch my video. Okay, repeatedly, if you watch the video and make a note, very beautiful note, and then sit for the exam, you have a high chance of doing very good in the exam. Okay, so let me drink little bit of water, then I will start normal distribution. Let me see whether you can remember something. If you have this symmetric curve, bell-shaped curve or normal curve, within one standard deviation, this is the mean, within one standard deviation from mean, which is equal to mu plus sigma, which is equal to mu minus sigma, okay? Within one standard deviation, what percent of data falls? First exam question, 68%. Thank you, 68%. Within two standard deviation, within two standard deviation, 95%, right? And within three standard deviation, mu minus 2 sigma, mu plus 2 sigma. In your first, within three standard deviation, mu minus 3 sigma, mu plus 3 sigma. Within three standard deviation, 99.5%. During that time, you had a golden opportunity to ask me a question. How about 1.5 standard deviation? How about 2.3 standard deviation? If this question, if you ask me during that time, then I would answer. That answer could be done by using normal distribution. Understand? Okay. Now, you have to again use the Python code. The purpose I spend some time with the Python as well as ask you to find the code. This code, if you use during exam time, your exam will be finished within 25 to 30 minutes. Okay. Now I want to compute this probability. So Z, probability of Z greater than equal to 1. Let me first do this. Probability of Z less than 1.5. I want to find this probability. How can I do this? So this normal curve, in this line, this is Z value. This line has all Z values, these lines. And above this horizontal line, under this bell-shaped curve, we have probability or percentage. Understand? So less than 1.5 means this area we want to find. This area we want to find. Understand? This area we want to find. So how can I find that? There is a normal table. So let me find the normal table. Normal table. I want to get a good normal table. Let's see, maybe I want to see the negative number. Maybe this one. Yes. This is the even a simple video, if you want to watch in the YouTube, there is a 5, 6, 7 second of ad. Okay. Even when I was uploading my video, they are asking me, do you want to promote these things? Put your credit card and this and that. Okay, let me find without video, let me find this one. Is this a negative? No. Let me find this one. Is this a video? No. Watch? No, I don't want that one either. YouTube. Yeah. This is the normal table. So my question, the normal table, the way it is written, are you seeing Z value? Okay, this is after that. So now if I want to, if we want to find less than 1.5, right? Let me show you from there. Let me show you from there. I want to find Z less than 1.5, right? Please take a look at the board and give attention. This is very easy. I want to find Z less than 1.5. I draw the picture 1.5. So 1.5 less than. So that is why I shaded this area, because this is less than. This is less than. So that is why like that way. Okay. So now I want to find positive 1.5. Come in here. See, even in here, unlock the continue for free. Simple table, they are asking us to give money. Okay. Hold on. Instead of that one, go to this one, find in there. Normal table, PDF. Yes. Finally, I found. Okay, so my question is less than 1.5. Take a look at that, less than 1.5. So this is the table. 1.5. Are you seeing 1.5? 1.5. I say Z less than 1.5. I want to find the area under that bell-shaped curve and to the left, because less than. So the answer is 0.9332. Okay. So I am going to write here 0.9332. 0.9332. This is equal to that area, that percent. That means 93.32%. 93.32%. So that means 93.32 frequency falls. Okay. Understand? 0.9332. So this is the explanations of this. So now if I want to show second one, probability of Z less than negative 2.16. 2.16 equal to what? Let me draw the graph. This is the graph, and this is the negative 2.16. So as it is less than, so that is like this, negative 2.16. Come in here, negative 2.16. Are you seeing negative 2.1, negative 2.1 and 6? 0, 1, 2, 3, 4, 5, 6. This is the answer. 0.0154. Are you understanding? Are you understanding? This is 0.0154. So I put, are you seeing here 6? Are you seeing here 6? Are you seeing here 0.06? So now negative 2.16. So that is the answer. Negative 2.16. So the answer is this one, which is equal to 0.0154, which is equal to 0.0154, which is equal to 0.0154. Clear, right? Can you please find these two probability by using Python? How can you find Python code to find normal probability? Did you find it? So you have to find a formula similar to in here that you previously find. It should be CDF. Instead of here, it should be norm, I guess. CDF. And what is the value? I said is 1.5, first one. 1.5 and our mean equal to 0 and standard deviation equal to 1. Let's see whether it will work. Is this the what we got? 0.9322. Did you get it? Are you getting it? Believe me, this exam will be 20 to 30 minutes if you know all of this. So now your question is, Professor, you are computing probability. What does this mean? The meaning of this, you have a data for normal distributions. From that data, you construct histogram and you add the top middle point of each bar and you add them by a smooth curve or line, and that smooth curve looks like a symmetric bell-shaped or mound-shaped. So now you are finding the percentage of frequency fall below a specific number. This is the explanation. So I am computing some percentage, some probability in here. What is the meaning of that? That is the meaning. Yes.
Where did you get the 0 and the 1?
Oh, fantastic question. Very good, Jana. So where did I get 0 and 1? This is her question. It has a 0 mean. It has a mean 0. And it has a standard deviation, mean equal to 0 and standard deviation equal to 1. If mean is different than 0, we will plug that mean. If is standard deviation different than 1, we will plug that. Thank you. I forgot to explain this thing.
So we should just assume it's that until told otherwise.
Yeah, until the question is mentioning that your mean is that, standard deviation is there. Thank you.
Okay.
This is a very good question actually. So in this case, Jana asked me question, what is 0 stands for? 0 is the mean of the normal distribution and 1 is the standard deviation. Okay. Okay. So now after this, I want to do now greater than 1. Now I want to do probability of Z greater than 1.5 equal to what? So probability of Z greater than 1. So I want to find 1.5 like this one. Exactly opposite, right? I want to find that this one. Greater than 1.5. So 1 minus 0.9. Fantastic. Do you understand his argument? Do you understand his argument? Because this one equal to 0.9332. 0.932. So now I want to find that one, which is equal to this one equal to that one. So in order to get that one, we just subtract this one from 1. Clear, right? So at least equal to what? 1 minus at most. So less than equal to at most, greater than equal to at least. Remember these two things. Less than equal to at most, greater than equal to at least. Okay. Now, after this, you will get probability of, so now greater than and less than terms is finished, right? Greater than and less than term is finished. So now, if it is greater than, you just do it in here, 1 minus that, this is your greater than. 1 minus less than equal to greater than, and less than could be computed directly by using CDR. Less than could be directly computed by using CDR. Clear, right? When I will solve real life problem by wording, then you will understand how to apply these things in real life problem. Like the way binomial distribution I solve, a hospital has 50 patients, and geometric distribution I solve. Okay, a person is seeking for a job or trying to meet a president. Like the way oil company digging well to get oil. Those are the real life problem, right? Similarly, normal distribution also is a real life problem that I will discuss next week. But today I am discussing also normal distribution that has a zero mean and a standard deviation equal to 1. Okay. So now I want to find these things. Z value less than 2.5, less than 1.5, between. How can I draw the figure? The figure is this. Figure is this. Here is 2.5. And here is negative 1.5. And I want to compute this area. Tell me, how can I compute that? Yes.
Take 2.5 minus
1.5, right? So what she suggests that I subtract this from entire that. Okay. So she suggested to subtract. Let me come here and change it in here. State. This is 2.5. I took 2.5 and then subtract minus state norm dot CDF, then negative 1.5, negative 1.5, 0, 1. This is what? This is called the between. Less than, greater than, between. Between negative and positive, right? Between negative and positive. There could be between negative, between positive as well. How? This is the same problem, but it is between negative. Between 3.1 Z negative 0.12. Between positive. How can you do that? 1.1 Z less than 2.9. Same formula, same. The way we have solved this one, we have to solve exactly same way like this. Okay? this horizontal axis contains z values. Okay. The bell-shaped curve, under the bell-shaped curve above this horizontal line, we have all percentage, that means probabilities. Okay. Percentage, so that means probabilities. Now, another thing I want to do, I want to find this probability of z less than a equal to 0.90. So what is the figure for that? This is equal to 0.90. Let me explain these things. Okay. First of all, let me explain these things. When it is z, this is equal to 0. Please take a look at the board. Very important thing I am telling you now. Okay. Are you looking at the board? This is the z value, and under this bell-shaped curve above this horizontal line, 100% frequency. That means probability equal to 100. That means 100%. That means probability equal to 1. Understand? So what we find in here, this is the probability. So this is a 50%. That is a 50%. 50% frequency in here, 50% frequency in there. So this is a 50%, that is a 50%. Clear, right? Now, suppose that 90% is given. This is a 90% frequency, 90% data falls in here. For what value of A, I will get 90% of the data. Do you understand the question? For what value of A, we will get 90% of the data. Are you understanding? Are you understanding? For what value of A, we will get 90% of the data. That is the question. So when we are a student, how to compute those things, that I am going to show you first by paper and pencil approach, and then I am going to discuss it by Python. Clear? So now the questions I am asking, for what value of A, for what value of A, we will get 90% of the data. Like at most 90% of the data. What happened? Why this disappear? Each time after a certain time point, it disappear. Very boring. Z less than A equal to 0.90. A, this is a, to write the sentence, right? For what value of A, we get at most 90% of the data. For what value? For what value of A, we get at most 90% of the data. That is the problem. For what value of A, we get 90% of the data. Now let me show you the paper and pencil approach that we use. 90%, right? Where is my table? Here, 90%. Are you seeing? It is always coming from here to all the way. I want to find 90% from there. I want to find 90% of there. Corresponding to that, I will find the Z value. Understand? So let us find the 90%. Let us find the 90%. This is the closest to 90%. This is the closest to 90%. Do you agree or not? Because if you add here 0.0003, then it will be 90%, right? Here, right? Corresponding to that, our value is 1.28. Corresponding to that, our value is 1.28, right? Corresponding to that, our value is 1.2. Our value is 1.28. So we write here, our value is 1.28. By looking at the Z table, we find that Z value or A value is 1.28, which corresponds 90% of probability or 90% of the frequency. This is paper and pencil approach, right? Now, how can I compute these things by using? Could you find that? So what you search, how to Python code for inverse Python codes for normal quantile. Python code for normal quantile. Python code for normal quantile. So it should be definitely, it is coming. I think it should be inverse norm of something like this. 0.90. Huh? We have to put PDF,
Yeah.
PPF. PPF. So 1.28. You remember by visiting that we got 1.28, right? By visiting that, thank you. By visiting that we got 1.28. But this line of code, if you just install the packages state.norm and PMF, CDF, 1 minus CDF and PPF will be your weapon. For normal distribution, next class, I am going to solve real life word problem, sentence problem. SAT score is normally distributed with mean 550 and standard deviation 50. A student took SAT exam from Macomb High School. Find the probability that his SAT score is greater than 570. Find the probability that his SAT score is less than 560. Find the probability that his SAT score lies between 560 and 580. What is his SAT score so that he will be in the top 91 percentile? The inverse problem that I just discussed. Okay. For what value of A, we will get 90% frequency. Okay. So I will discuss those things in the next class as well as Poisson distributions. Then we are done for the another exam. See, I'm giving you a small exam. Okay. So you can take the exam. Please watch the video. Watch the video, and before this Sunday, watch this video 2-3 times. Write the note and take the exam. It is easy. Okay. Question, comments, problem? Personal problem that you do not want to share? See you in next week, okay?
First,
Bye, Grace.
Bye.